Thank you everyone for waiting. Next, I am here to present to you a talk about another important issue in cannabis. I am very happy to present to you Stephen Goldman, Lab Director of Phytatech SM, a quality control lab for cannabis in Denver, Colorado. Stephen Goldman is an analytical chemist with extensive industrial and academic laboratory experience. He is an expert in GC, HPLC, and mass spectrometry, chemical and biochemical engineering, as well as project and business management. Please join him in his presentation detailing how cannabis analysis labs developed, why they are important, and what you will need to test your products for so that they can be sold in a legal market.
Hello, my name is Stephen Goldman, and I will be chatting today about testing cannabis contaminants, testing and effectiveness. Today, we're going to jump into all aspects about testing, what a testing lab does, what kind of tests they run, why testing is important, and at the very end, I'll share some data, hopefully to convince you why testing products is a good idea for public health. So I'm the lab director at a facility in Denver, Colorado called Phytatech. We have been open since 2013 when the recreational market was legalized here in Colorado. And we exist solely to make sure that the citizens of Colorado are consuming safe and properly labeled products. So one of our big pushes is public health, obviously. And we're actually regulated by two public health departments, both the city of Denver and the state of Colorado. So it's a definite focus for our laboratory. Today we're going to touch on 7 main topics, 7 themes. The first one is about cannabis itself and explaining why it's so complex and why it's so interesting for a testing laboratory. Then we're going to go through some cannabis processing steps, how we go from flower to edible. And at each of these steps, what are common contaminants entering the manufacturing stream, and what do we want to look for at each of these steps? Finally, we'll get into testing labs, some of the assays and endpoints, features of high-quality labs, quality assurance, accreditation, proficiency testing, things like that. And then we'll share the data about whether testing labs are actually functioning in the state of Colorado right now. And so let's jump right in. Our first topic is going to be cannabis and how it's a complex matrix. So cannabis inflorescence, inflorescence just means flower, is a really complex matrix because it's composed of over 500 different molecules, over 500 different compounds just in this flower. And you can see how heterogeneous it is. Here we're even blowing up the picture of the flower. And you can see the trichomes, so really homogeneous solid liquid phases, and as well as vapor with the terpenes. So we've shown a little key here of green, and typically when people think of cannabis inflorescence, they think of just this little yellow part, the cannabinoid part. That's where your THC, CBD, and a lot of the medicinal molecules are going to be located. But it's only a tiny sliver of the full profile of molecules that are located in cannabis. Some of the examples of these are terpenes, flavonoids, pigments, waxes, pectins, as well as the plant matrix molecules like cellulose and lignin. So it's a really complex matrix because from an analytical chemistry point of view, we have to deal with all of these types of compounds when we're going to look at developing our tests for THC and CBD. And what I mean by that is, if we continue looking at our key here, we start with a lot of material, but this green material is not really what we want in our tests. So we need to eliminate that from our processes. It's the same way that manufacturers are eliminating those as they purify THC and CBD. So as we go from lots of compounds to fewer, we need to be cognizant of what's left and what was kicked out during our manufacturing process so that we can really hone in our analytical techniques. Because of this, testing labs have done a myriad of method validations, proving that what they say is in that plant is actually in the final product. So as a testing lab, if I run a potency analysis, I need to make sure that I extract from that starting flower material 100% of the cannabinoids and nothing else, no lipids, no terpenes, nothing else to make that potency run as clean as possible. This is kind of the difficulty in natural products chemistry that chemists and engineers have been facing for many years. So it's not new, but what's new is that there's no standardization, no federal methods, no banks of reference libraries that can be used for testing labs to start up. So most are starting from scratch, so it leaves a really interesting environment for testing labs to exist. So because it's so complex, let's just go through a quick tutorial of some of the processing steps that a lot of manufacturers are doing in North America. So the cannabis inflorescence, the flower itself, is grown indoor, outdoor, in greenhouses, in many, many different ways. All of this flower is either being sold as flower or turned into concentrates. Concentrates are some of the most fascinating because there's so much product diversity here. So whether you make using butane or ethanol or CO2 or heat and pressure, you can come up with many, many different compounds, bubble hashes, waxes, shatters, keefs, and the concentration range of cannabinoids here can be anywhere from 30% up to 100%. So it's really a fascinating subclass of cannabis products. From these concentrates, we can then go on and do more higher order processing. These things would be like distilling the cannabis products, for instance. Distillation is a really high energy technique, but you can get a lot of higher purity compounds here. Isolates and distillates would both be considered higher order concentrates that have been produced through higher order manufacturing. And then oftentimes these distillates and isolates are what's actually being manufactured into edibles because they have higher purity. It's a little easier to do the dosing scheme when you're making brownies, chocolates, drinks, teas. There's many, many different types of edibles, everything from personal lubricants to coffee. So really fascinating class there as well. And because it's such a wide life cycle from flower to concentrate to higher order concentrate to edibles, we have to be cognizant of the different types of contaminants that can enter at each of these processing points. So for flower and trim, microorganisms, heavy metals, and pesticides are going to be really important to look at. Microorganisms, because these are plants and they're not sterile creatures just like animals aren't. So we have to make sure that the normal microbiome is present and no plant or human pathogens are present on these materials. Pesticides is more of an agricultural view. If growers are applying something, we want to make sure that it's a safe product or that it's at a level that won't be deleterious to human health if consumed. And heavy metals are the same category, really, really toxic molecules that definitely have a lot of hepatotoxicity. And this plant is a bioremediator, meaning if you plant it in soil or water that has a lot of heavy metals in it, the plant is going to suck those up really, really quick. It's really effective at bioremediation. But because of that, we have to make sure that it wasn't grown in these environments and therefore is contaminated. As we move into concentrates, some of these become less important. Still, heavy metals and pesticides are always important because they're so dangerous. But now we don't really care about microorganisms because the process of producing flour to concentrate in many cases can sterilize the product, meaning we're doing it at such high temperature and pressure that a lot of the microorganisms, the bacteria, and the fungi, the yeast and the mold are going to be destroyed during that process. But now we want to make sure that the residual solvents used during that process, so meaning the ethanol, the butane, the heptane, the hexane, that those solvents are now at low enough levels that they also won't be dangerous to public health if consumed. So on concentrates, we measure residual solvents on every product. As we go to these higher order processed concentrates, we're going to look at all of those tests still, solvents, potency, pesticides, and heavy metals. But now we're going to also look at API degradation. And API is active pharmaceutical ingredients. So in this scenario, it would be THC or CBD. Oftentimes when we're doing distillation or producing isolates, we're putting so much heat and temperature and energy into the process that the THC and CBD actually starts to break down. In some cases, it will isomerize or form different products. So we want to be mindful of what we're doing to the THC this whole process as well and make sure we're not going overboard and degrading it. And finally, in edibles, we then test microorganisms again. You'll see it pops back up on the list. And why is that? Well, it's more of a food safety concern. A lot of kitchens that are producing these are going to be, run by humans, and so again, there's the possibility that microorganisms are going to contaminate the products again. This is similar if you eat at any restaurant, right? If someone prepares your salad, they're going to want to be mindful of making sure there's no salmonella in that salad, and the same safety profile is true of edible products here, which is why we're testing for microorganisms again. So now that we've kind of looked at how these things are processed and how contaminants enter, I want to dive into the contaminants themselves. What am I talking about when I say a micro test? So let's start there with the biological contaminants. Biological contaminants are fungi, mycotoxins, bacteria, yeasts, molds. So here in Colorado, we're mandated to test for salmonella, as well as Shiga toxin-producing E. coli strains. Those are the two bacterial strains. And we also do a total yeast and mold screen. And that's going to measure the number of yeasts and molds that are on the flour products. So bacteria are the types of things that we definitely don't want any in the product. So any bacteria in the product will fail the product. Yeast and mold is not that case. A healthy flour is going to have a high number of yeast and molds. So here the state of Colorado has set the limit as 10,000 colony forming units per gram. Anything less than that is going to pass. Anything higher than that is going to fail in the state of Colorado. Different states in the United States have different levels, but you'll commonly see 10,000 or 100,000 CFUs per gram. The types of fungal contamination are actually the aspergillus, the yeasts, and the molds. And this is a picture of a Petri film, which is one method to measure yeasts and molds on flour. And this is commonly used in a high number of cannabis testing labs in Colorado and the United States. And what happens after you incubate the sample and shake off all the microbes and then plate them is they'll grow like this. And depending on the different colors, whether they're black or light blue, there are different species. But all of those would be counted. Each of those is a colony. And therefore that number after the dilution and subsample mass would give you your CFU per gram. But there are also agricultural contaminants, and these are often referred to as agrochemical, meaning the things that are applied while you're growing a crop. And so the number one class of compounds that most people will think of would be your pesticides. These are going to be the carbamates, organochlorines, organophosphates, pyrethroids. These are the types of things that other crops, corn, wheat, tomato, maybe it's legal to use these types of products at a certain concentration in other crops. But in cannabis, it's unknown what's going to be really healthy and really toxic. So a lot of states have zero tolerance, or if not zero tolerance, really, really low levels to mandate the use of some of these compounds. One example is DDT, and we bring that up because most people have heard of it, and most people understand that once it's sprayed in nature, it sticks around for a long time. The half-life of this compound is really, really long, so if I spray it on a crop, you can expect to see it in soil and water for many, many weeks and months after the process. So it's not spray it and forget it. You could fail a test after spraying a pesticide months down the line, which has been an important lesson for a lot of people here in Colorado. Another example of cannabis specific is myclobutanol. There's a product called Eagle 20, and a lot of cannabis growers were using this product in the state of Colorado. The active ingredient is called myclobutanol, and it's a really nasty one. So that was one that we still see failures on in Colorado, even after testing for many, many months now. It's still in a lot of facilities. So the limits, the regulatory limits set for a lot of these pesticides here in Colorado are really low part per billion. So from 10 to 70 part per billion. It's pretty conservative. Other states are a little higher. Sometimes you'll get into the hundreds of part per billion or low part per million. But it doesn't take a lot of these pesticides, and these products will fail. So the challenge for growers is to minimize their use of pesticides, all while controlling the growth of microorganisms, right? You apply a pesticide to kill a microorganism, a yeast or a mold. So that's kind of the balance, the yin and the yang. You have to grow these things so that microorganisms don't take over, but also not apply really dirty pesticides that are gonna make your consumers sick. Residual solvent contaminants are a little easier to understand. These are the solvents that are applied during the process where we're making concentrates from flour. And the list can be really long. There are lots of hydrocarbon-based solvents at any chemist's disposal. But you can see from this list that most of them, have pretty chemical-sounding non-safe names. Things like benzene, chloroform, methylene oxide, methylene chloride. Those are really, really nasty Class 1 chemicals. Definitely that you don't want to have used in any of your manufacturing process. Some a little further down the list, butane, ethanol, isopropyl alcohol, those are a little safer, but we still want to make sure that they're below certain levels in each of these products, especially if people are going to be inhaling them directly. So it's direct exposure to the lungs for all of these solvents, which is why we really need to pay attention. And then, just to bring it up again, something that everyone should keep in mind as they're getting into the higher order processing of cannabis concentrates, that would be distilling mainly, is really make sure and test along the process. You don't want to just distill and put it at really low vacuum and really high temperature and expect to get 100% THC out. Oftentimes people will distill and will test the product that's coming off, and it will be 20% THC with 70% other degradation products. So they've actually degraded their THC more than they've actually concentrated it through distilling. So be very cognizant of what you're doing during the concentration process. And finally, heavy metals. These compounds are really, really nasty. Most of the labs are running them on ICPs or ICP mass specs. And it's really important. There's been a really elegant thesis study done here in Colorado State University where they were spiking selenium and hemp and letting hemp accumulate, and in oftentimes the flower, the stalk, the leaves were accumulating the selenium concentration 20 to 30 times higher than what it was spiked in the soil. So if it's there, if any heavy metals are there in the soil or the water, hemp and cannabis plants are going to just suck it straight up and accumulate it. So in Colorado, we have a lot of mining, petroleum industries like that, which may have left a little bit of contamination in the soil. So definitely test soil, definitely test water before you plant these plants for heavy metals to make sure that this isn't going to be an issue for you. And the limits for heavy metals is pretty low. Depending on the state, these things can be anywhere from 100 ppb to 5 ppm. Depending on the metal. Most states are mandating testing for these 4 metals minimum: arsenic, lead, mercury, and cadmium. But other ones can be on the list as well. You might want to be, looking for chromium, for instance, if you're using machine trimming. Oftentimes those machines are coated with, stainless steel or chromium, so maybe little bits of that are coming off as you're doing your trimming. But these are really toxic molecules, so definitely something that we want to pay attention to. So let's kind of jump into some things that you may have heard about testing labs. What's the role of a testing lab? What does a testing lab do? What are some myths? I think these will be good to cover. This is a really good list of what a high-quality testing lab can offer their clients. You shouldn't think of a testing lab as a regulatory checkbox. You should think of it as a partner in your manufacturing process. The last thing any manufacturer wants is their brand to be affected by a recall or something negative like that. And so testing is a way to ensure that your products are going to be safe and your brand, therefore, is safe. Moisture content, terpenes, metals, mycotoxins, even formulation assistance. We do all of these things on a weekly basis. And so all of our clients should feel comfortable pushing their labs on the validations of these methods, as well as reaching out for assistance once they're just starting their businesses, so that it's not such a uphill struggle when you start testing for these contaminants. You know what to expect along the way. What are some testing myths? Every lab that tests cannabis tests it the same way. That's a big myth. Like I said, there's no standardization. There's no federal body mandating how testing labs should be testing products, which means that testing labs can come up with their own validation, right? The minimum criteria is that they prove that their methods work for them. The way that they do that is through proficiency testing, meaning a third-party body makes a homogeneous standard, sends it to many labs, And if the lab tests it accurately, they'll come back with a passing value. If not, they'll come back with a failing value. Proficiency testing isn't that old in cannabis testing. It's maybe 2 years old. And so in the United States, we have 3 or 4 third-party manufacturers of proficiency tests. But definitely nobody is telling the lab how to test the product. As long as they get a passing value from that proficiency test, they should be good to go. So if you use 2, 3, 4, 5 testing labs, don't expect them all to do the same thing. Very, very likely they're all doing a different method. Testing instrumentation is highly precise. There's error in everything we do, right? So a big portion of what a lab does is measure its uncertainty. So is the balance different? Is the temperature in the lab different? Does the analyst make a difference? Every test should have a measurement uncertainty on it, and that lab should be able to report to you what their measurement uncertainty is by test, by analyte. It's absolutely normal that there's error in every process. Typically, results are much, much tighter than 5%. I would say even less than 2% is typical of what I see in labs in Colorado. But if you submit 10 flower samples, you absolutely should not expect the same value coming back for each of those 10 samples. There's huge amounts of variability on the manufacturing side and a small amount of variability in the testing lab, so you're never going to get the same value coming back. Tests take a few hours to run. We have a lot of our clients that bring us rush samples, and they want their potency value back in an hour. And they say, well, hey, your method takes 7 minutes. Why can't I get a result in 1 hour? Well, it's because there's a lot that goes into that value, right? The lab is checking the sample in, extracting the sample, adding internal standards, running it on their method. And their method batch runs are started by QCs. They contain CCVs, the continuous calibration verification. They probably have a curve at the beginning and the end of each run. All unknown samples are bracketed by CCVs. So about a third of every run is actually QCs and controls and blanks that the lab will run. Our lab runs matrix spikes. We do duplicate preps. We have a laboratory control sample that we spike. So there is much, much more that goes into running one sample than just running one 7-minute sample and getting the test back to you. And lab uncertainty is greater than manufacturing uncertainty. This is the biggest myth out there, probably. Again, the measurement uncertainty in a lab can be anywhere from less than 5%, hopefully less than 2% as well. But ask your local labs; they should be able to hand over their measurement uncertainty per test. The manufacturing uncertainty, on the other hand, can be anywhere from 10 to 40%, depending on the quality of the SOPs. We've seen butane batches go from 10x difference than what the actual client thought that it was going to be. So the manufacturing unreliability is huge, especially given the heterogeneity of the starting material, the flour that people are using. One potency test of a 1,000-pound flower harvest is not going to give you the true heterogeneity of THC and CBD concentration in your harvest. It just isn't possible. It never will. So definitely think of your manufacturing process as being one strife with heterogeneity. And again, the push for standardization is ongoing, right? There's no federal guidelines. Each state is kind of rolling out their own regulations. Some are medical, some are recreational. Mexico is doing some interesting legalization things right now. So the way that one lab in North Carolina extracts and tests their samples and the way that the lab in Mexico City is going to extract their samples is going to be pretty different because there's no top-down enforcement of what's going on. So one of the advantages is involving your lab in a network of locations. That way you can compare extraction methods, SOPs, tests, method validations, lab to lab, and kind of pull the strength from each of the lab locations and make a kind of a super set of procedures that are going to be much stronger than if you were one lab alone. And so that's what we've kind of done. We've partnered with a lot of labs in Florida, Oregon, California, Canada, to pull the best across the nation and combine into a much stronger team. And I would definitely encourage everyone, to consider a national presence as a strength, not a weakness. And why is it a strength? It's because without standardization, we have no consumer confidence, product efficiency, and consistency. If someone in Tennessee buys a CBD product online and it has no CBD in it, that person will never ever buy a product like that again, right? So we need to avoid those situations where there's dangerous or mislabeled products in any market that it comes out. Quality assurance is a big one, right? If you don't have oversight, then how can you actually prove you're doing what you say you're doing? In our lab, we're regulated by so many bodies. We have the Colorado MED, which is the Marijuana Enforcement Division, housed in the Department of Revenue. They audit us whenever they want. They don't have to tell us that they're coming. The City of Denver Public Health Department, the state CDPHE, the Colorado's Public Health Department, they audit us on a regular basis. We also are audited and accredited according to ISO 1725 standards, which are testing standards, which means that there's an ISO accrediting body coming in and auditing us as well. The reason we go through all of that auditing is because we want to ensure confidence in all of our to all of our clients and consumers that whatever number comes out of our lab is as good of a number and as high quality as it can be. And that's true of manufacturers as well. You need to have third-party oversight. You need to control chart your products. You need to make sure what you're doing batch to batch is documented so that you can prove to clients and consumers that you're manufacturing as good as you possibly can until there's a little more federal oversight on all of these procedures. What are we talking about when we say standardization of cannabis products? This would be batch size, sampling and testing frequency, standard prep, which certified reference materials or CRM materials are you using, instrumentation, making sure everyone's running potency on an HPLC, not a GC. People are using mass specs for pesticides and heavy metals so that they can meet action levels for contaminants. So there's a lot that needs to be thought about from a regulatory perspective when setting up testing labs and when setting up an industry of growers and manufacturers. So each of these things you should have a procedure for in your facility. What are common issues? Well, the issues I think we've touched on a little bit is that there's no federal oversight. Each state's rolling it out little by little. CBD manufacturers consider themselves a little bit different from cannabis manufacturers, which maybe is probably not the best mindset to have. And a lot of the samples that are coming out of this environment have such high variability that it's impossible for consumers to have trust. How many of us have seen a news story where a testing lab tested 25 or 50 CBD products and found that the majority were mislabeled and some of them didn't even have any CBD in them at all? Those are the kinds of sentiments and ideas that are really going to ruin the industry for consumers when they have no trust in the products. And lastly, commercial adulterants. Let's bring up some data. And this is a little old now out of California, but it concerns pesticides. So we can see in flour here, we're looking at just one common pesticide. This is bifenthrin. In flour, the average part per billion is pretty low. This is the concentration in flour. When they tested concentrates that were made from this flour, you can see that the level is much, much higher. There was almost a 10x concentration of pesticides, of this particular pesticide, in the concentrates made from the flour. So if we're spraying our flowers with pesticides, they absolutely are going to be showing up in the concentrates, and the concentration, which will depend on the type of process you're using to make those concentrates. But pesticides are definitely coming along in the process. Heavy metals are definitely coming along in the process. Mycotoxins are definitely coming along in the process. So if we don't catch these contaminant points when they enter the manufacturing process, meaning the flour, then it's going to show up in concentrates, it's going to show up in higher ordered concentrates, and it's going to show up in edibles, and that's a serious problem. Here's another summary, also out of California, of the percentage of products that had detectable residue. 71% of flowers. And look how many are failing OHA or EPA levels. It's really a problem when you first start testing to find out what's actually in these products. So don't be surprised to see these things And definitely start to plan on how you're going to deal with them as a business. Do you want to take that risk of dealing with contaminated flour if you make concentrates? Always remember, people are using this product as medicine. You know, many of the states on the standardization map that we showed have legalized medicinal use but not recreational use of these products. And many of these using it medicinally are immunocompromised. So if their immune systems are compromised and we're putting in contaminated product, the effect is going to be negative ×2 for them, right? They don't have an immune system to fight off those contaminants to begin with. And so always remember who we're making these products for, right? This is medicine, and we should treat it as such. We should make sure the medicine is as accurately dosed and as safe as possible. And all of that comes down to harm reduction. Prevention is primary, right? We need to make sure that contamination should be avoided. This is good agricultural practice. It's good manufacturing practices. At the lab level, it's GLP, good laboratory practices. All because we want to minimize the contamination that are in these products. It's our duty to do that if people are going to use them for medicine. So let's dive a little bit deeper into a cannabis testing lab. What are some basic QA tests that we can run on cannabis? Here's the abbreviated list of tests that we looked at again, and the instrumentation in the lab that we use to run them. You'll see moisture content. You can run a couple different ways. THC, cannabinoid profile, terpenes, that's all chromatography. We see this word chromatography showing up on a lot of these tests. And so what does that word mean? Chromatography is actually just the separation of a mixture of molecules. It means to separate. So we take a complex mixture of molecules, just like cannabis, and we purify it and separate them out so that we can measure it. If we were going to start with flour, remember it has up to 500 molecules in it, and try and measure them all at the same time, it would be almost impossible. But if we separate them out and then measure them one by one, it becomes much more feasible and easy to do. So what do I mean by this? This is a cartoon, but you know the principles are exactly the same of what's happening in a lot of our tests: potency, residual solvents, terpenes, mycotoxins, pesticides. They all use chromatography. And so we put a molecule in, and this would be our column, this cylinder, and it's packed with little beads. And these beads are going to interact with the molecules that we pass through it. And some are going to come out real fast, and some are going to come out real slow. They're going to interact many, many times and then come out slower. So you can see if we put a mixture of stuff in, some are coming out faster, some are coming out slower. You can see how we separate compounds like that. And then at the end we collect them, or we use a detector to detect them at the end. And so this principle of chromatography is true in a lot of tests that we run. You'll see HPLC, that's high pressure liquid chromatography, meaning it happens in the liquid phase. We're pumping liquid through here. And you'll see GC, which is gas chromatography, and it's the same principle, but now we're doing it in the gas phase, so we're pumping gases through our columns. GC versus LC is pretty easy. Here's a picture of a GC. Gases move faster than liquids. Liquids move faster than solids, right? That's pretty basic chemistry. Because gases move faster, the columns in GC are usually around 30 meters long. They're wound up in a coil inside here, shown in this little cartoon. Liquids move slower, right? So the column in HPLC is typically much, much smaller. You can get anywhere from 10 to 25 centimeters. And the same separation power happens in each, just given that gases and liquids move a little bit differently. Liquid chromatography, this is kind of an older unit. This is an HPLC. The solvents will be on top. You'll have a pump that will pump it through your column, and then you'll have a detector on the other end detecting the molecules as they come off. Most labs are using UV detectors to measure cannabinoids. They have limits of detection down in the part per million range, which is more than sufficient for flours and concentrates. Remember, those things are 10 to 100%, so definitely much, much higher than part per million concentration. Pesticides and mycotoxins, heavy metals, those things are much more, we're concerned with levels much more concentrated than that, so we want to be down part per billion or part per million. And so we won't use a UV detector there. We'll use what's called a mass spec detector, which as its name infers, uses mass to detect these compounds instead of the absorbance of the light. And here's an actual real-world chromatogram showing a potency separation using HPLC. So you can see the x-axis here is time, the y-axis would be absorbance or peak area. And you can see once we separate these cannabinoids, they're much, much easier to measure. So you can see a couple cannabinoids are labeled here. And we can easily measure the THC peak area as compared to the THCA peak area here because they're separated. If they overlapped in one peak, that would be impossible. Hence why separation is so important. So now that we know kind of at a high level the tests that labs are running and we know how they're running those tests using chromatography, what are some of the other quality systems that are important for labs to keep in mind to make sure that they have high quality, high functioning data coming out? This is a list of some of the QA things that good labs are going to want to address. They're going to want to get accreditation. So that would be getting their state CDPHE to accredit them, or ISO 1725 accreditations, TNI, whatever is available to them. The more accreditations, the better, right? The more people come in and validate your work, the more security you can have in the number that's coming out of your testing lab. You definitely want to maintain your independent third-party status, right? If I have one big client who is paying me $1 million, maybe there's a little bit of pressure to give that client the number that they want. And so it's really important that you have the procedures in place so that your staff and your data systems maintain impartiality to those bigger clients which may be pressuring you for a pass instead of a fail. You want to educate. A lot of this is new. Nobody's been testing cannabis for more than 10 years. So a lot of this is education. What do testing labs do? It's not a black box, right? You should be able to give tours. You should be able to share your method validations. You should explain what the tests mean that you're running. Also that there's more confidence in your clients and more confidence in the consumers. You need to provide accurate test results. The last thing you would want to do is make up a number. You never want to do that. You know, and unfortunately there are a lot of labs that are still doing that. They are taking samples in, not running any tests, but producing data somehow, which is why transparency is so key in this industry, especially as it grows. Service level agreements and quality partnerships with your clients are essential. You know, we always tell our staff when someone fails a test, it's not a bad thing. That's an opportunity for improvement. If you can teach a client how to never fail a test, how to improve their manufacturing process so that they know that they're driving off butane, so that the butane levels are always lower than the regulatory ones, and they'll pass a residual solvent test, you've now made a partner with that client. And so, you know, never consider a fail the end of the transaction. A failing test is always the beginning of the transaction in our experience. And you actually want to work with your competitors. In Colorado, we have, you know, anywhere from 9 to 11 testing labs, depending on licensing, and many of them are some of our greatest resources. You know, we can get on the phone, call them, hey, we're having trouble with this. Are you experiencing anything similar? Hey, our mass spec broke. Can we send you a couple samples? So although we're direct competitors in an open market, it's always good to consider your competitors a resource, right? You should never compete so hard that you can't communicate, because it's a growing industry, right? And you couldn't do it. We couldn't be the only testing lab out there. We need them to exist, right? And in order for there to be good client satisfaction in the industry. And this is an idea about method uncertainty, but you know, the principles hold true for a lot of different ideas, and that's one of constant improvement. If you come up with a validated potency method and then you run that for 20 years without ever improving it, you know, you're really doing a disservice to the industry. You have to maintain constant improvement because things are changing so fast day to day, right? There are new products coming online, there are new clients, there are new countries legalizing. And if we don't constantly improve, then we're going to die in the fast turnover of the industry. So in this idea, if we want to run any test, we design the parameters of that test to be appropriate, and then we qualify the instrumentation that's going to be used in our procedure that's going to be used to run that test, and then we continuously verify that process. And this is kind of a cyclical thing. We always have to be evaluating error probabilities. We always have to be evaluating risks. We always have to be measuring risks in order to minimize them again and again and again. And each of these uncertainty measurements and risk probabilities therefore informs the design, qualification, and continuous verification processes. If you don't have a continuous improvement procedure like this in place in your lab, you need to put one in practice immediately. Without this, risk-based thinking and risk-based action and risk-based design, you'd be doing yourself a disservice. We definitely see instrument shift. We definitely see standard quality go up and down. We definitely see manufacturer variability be high. We see our analysts, get comfortable in running a method that they've run 10,000 times. So we need to continuously change our risk probability lens in order to capture all of that so we can continue to improve and not get stagnant. This is an important part of ISO 17025. It's also an important part of TNI. Both of these are pretty document-heavy accreditation methods. They look into method validations, SOPs, proficiency testing results, and PT plans. They make sure that your employee training is really high and that all the technician DOCs are in place. You're looking at corrective and protective actions, annual auditing, looking at your internal auditing versus external auditing of all your procedures. And none of this has to do much with testing, right? But look at everything that testing labs are doing on the behalf of their clients, just to make sure that the number that they put out is as high quality as it can be. So enough about the quality of testing labs. Let's look at some testing data, and this is all going to be in the United States, mainly in Colorado, but I'll try and share where it's from. And I'm going to show you the date that a test was considered mandatory. So the date that we started testing in Colorado, and then what happened after the next couple of months. So here in April of 2015, the state of Colorado made mandatory residual solvent contamination testing. So prior to it, it had not been tested for in the market. And in April and May 2015, 28.5% of all products, of all tests for residual solvents failed. Almost a third of all products failed once we started testing that product. Look at just 6 months later, down to 5%. And look at 2 years later, 0.6% of products fail for residual solvent contamination. So what happened is that all of the clients that were now failing asked the labs, well, what happened here? How do I control this in my manufacturing process? And the education got better, manufacturing processes got better, and the testing fail rate dropped dramatically. This is exactly what you want to see, the great trend out of the gates. The same thing happened for microbial contamination testing in Colorado. October 2015, it became mandatory for flower to test microorganisms in flowers. The failure rate was about 20%. It held true for the next month, November, 21%. And then December, 11.4%. So we start to see this decrease, and just 1 quarter later, January 16, the fail rate was 1.8%. So it dropped dramatically. Again, manufacturers are learning how to have good agricultural practices and learning how to deal with these microorganisms. But it's not only in Colorado where we see this. So this is from some of our labs in Oregon, where you can see pesticides, and we can even see it by region. But October 2016 and 2 years later, we're seeing drastic decreases in the number of fails on pesticide crops. You can even see by location. These are 4 different locations in Oregon, and then an average. And we can see, based on where they're located in the state, who's using more pesticides and who's using less pesticides. So really fascinating trends that you can start to analyze from the testing side. And this is a lab, one of our competitors, friendly competitors out of Nevada. This is Cindy Orser's lab, Digipath. And she shows the data a little bit differently, but here we're looking at passing rates, not failure rates. And so you can see pesticide testing started, only about 75% of products started passing when they started looking in Nevada, which means 25% were failing, right? And look what happens. By December, just 6 months later, we're almost up to 100% of people are passing for pesticides. So again, the same trend. Lots of people failing, very few failing. Same for micro, almost half. Look at that. Half of products were going to pass and half were failing for microorganisms in Nevada. 6 months later, up in the 90s are passing. So testing labs definitely work. They definitely are improving the manufacturer's skill set. They're definitely improving the safety of products that customers and clients are buying on the market. And they're definitely starting to analyze that data at a high level to make sure that they can feed the regulatory environment and tell them what's a risk and what's not. So in general, I would say that testing labs are very important to the manufacturing process. That's all that I have today, so here's my contact information. Feel free to reach out at a later date with any questions, and I look forward to answering your questions now.
Hey, Stephen, thanks for joining us today. That was a great presentation.
Of course, thank you.
So we have some questions for you with your expertise. I want to say before we begin the question and answer that we lost 2 of the questions that were asked. So if you did ask a question in the chat box, go ahead and just retype it into the chat bar. We'll start with the first question one of them that we got out of the chat box, which is it possible for gas chromatography to discriminate between THCA and THC? Or can you only do this with liquid chromatography?
You can do it with both. I would say that HPLC, liquid chromatography, is the gold standard. That's probably what my lab and all of our competitor labs are using is HPLC. But traditionally, years ago, decades ago, it was run on GC. The problem with GC is the inlet temperature is really hot. So if you put THCA on or CBDA on, it immediately decarboxylates into THC and CBD. To be able to tell the difference, you have to do studies with pure standards of THCA to get the decarboxylation percentage, and then back calculate with math. That's a step that's unnecessary on liquid chromatography, and so most people use liquid chromatography to do it.
All right, so our next question is, how soon should I be testing my soil before I start growing if I'm looking to have an organic, if I want to be certified organic with my weed?
As early as possible. It depends on a couple of things, whether you want to get a soil contaminant or a soil quality marker. Soil contaminants would be things like pesticides and heavy metals, and if those are in your soil, you want to know right away, because there's not a lot you can do to remediate. So maybe you even want to plant in a different spot. But soil quality markers would be things like phosphorus, silicon, calcium, aluminum. And those you can test a little later because those are problems that are fixable. If you need to add any fertilizers or any other organic reagents, you can do those prior to getting in the crop. But test your soil for contaminants as soon as possible.
Okay, that makes sense. So the sooner the better. And our translator just asked if you could speak a little bit slower so they can get a better translation from you. Okay, so the next question is, can we send samples to Colorado from Mexico?
You cannot yet, although that may change. Colorado has some regulations that prevent laboratories from accepting samples through the mail. I do think that in 2020, so next year, I do think that those regulations will change and it'll be a little bit more flexible. So currently, no, but hopefully, yes.
Perfect. I'm going to make a note of that. Okay, so we have another question. Are there any protocols available for LCMS, or do they have to be developed from scratch? So I think methodologies is what they're asking.
Sure. And most people are using mass spec LCMS to test for pesticides. They're using HPLC with a UV detector to test for potency. So for the pesticide assay, you definitely have to validate that in-house. There are some methods that can get you started. For instance, if you buy a mass spec from Shimatsu or Agilent or SciEx, anybody out there selling mass specs will be able to give you a method to get you started. But the pesticides that we test for in Colorado are different than the pesticides that the Mexican government may be interested in looking at. So because there's different analytes, you're going to have to do different method development and different method validation as well.
Okay. All right, so we have one more question for you. Again, I'm going to say if you had a different question, please type it into the chat box now, because we did lose 2 questions. But so maybe our final question is, are there any labs testing for cannabis that you know of in Mexico?
I know of none. I've heard of a couple that are getting up and running, but nothing open now.
Perfect. Straight into the point. Okay, so I don't see any other questions coming through, so that will conclude our question and answer session. Thank you so much, Stephen, for coming on and chatting with us and giving us a great presentation today. In a few minutes, I will introduce the next speaker.